Good morning, ladies and gents and ladies. Today is our Scatterplot reteach, and the purpose of this video is just to make sure those of you who didn't quite get all of it, want to give you another chance to try to understand this topic, or maybe you weren't there, maybe you just missed a piece, or maybe you wanted just a friendly reminder about what scatterplots are. So this is a short reteach, and you'll see the little GIF of Buzz and Woody. It says data, data everywhere, because that kind of defines what a scatter plot is. It's data that's everywhere. But more specifically in math class, it's data that is spread apart on a graph. It's spread apart everywhere on a graph. But you don't just see this idea of a scatter plot in math class or scattered data in math class. You'll see it when you watch the news, specifically the weather, and you'll see scattered showers is what they'll call this. And it's what it sounds like. There's showers here, showers there. Some people got a little, some people got a lot. Some people didn't get any rain. Things are just scattered apart across the radar map. You'll see them at weddings when the bride walks down, like here comes the bride, and they throw all the beautiful flowers on the floor of the flower girl, and then the guy is crying, looking for his girl to come down. Or maybe I'm just talking about myself, but you also see it in video games. When the game starts, he'll show you where all your opponents are that you have to slay. But the data is scattered across the map. It's not necessarily in a perfect line. However, sometimes the data is scattered in an organized way. So in a math class, when you see a scatter plot, which again is data that is spread apart on a graph, you're going to see it one of four ways: in a positive linear association, a negative linear association, nonlinear association, or just no association. Now, some of you get hooked up on the words. Okay, don't let the words scare you. Just make sense of them for yourself. Whenever time you see the word linear, which you see here in yellow, that just means a straight line. Anytime you see the word association, that just means a relationship. And then nonlinear means not a straight line. So if you read that with these definitions in mind, this first graph here, this first scatter plot, is a positive straight line relationship. This next one is a negative straight line relationship. This one is a non-straight or not a curvy line relationship. And this one has no relationship at all. This is true scattered data everywhere. And so on problems that Ms. Hill shows you, Ms. Gray shows you, Mr. Lotta shows you, Ms. Kano shows you, or I show you, we need you to figure out what type of relationship is this. Now, well, how do you go about doing that? Well, you're going to use this thing called a trend line. A trend line is a line that tells you how the data is related, aka how it is trending or associated. Okay? Because in these first two, I kind of just told you, I was like, hey, this is positive, this is negative, this is nonlinear, but how could you determine that for yourself? So right here on slide 9, I want to show you whether you're using Google or a sheet of paper or even on the STAR test, there's a feature where you can draw a straight line. And so you're going to draw your trend line, which is a straight line. Okay, remember, a trend line is a line that tells you how the data is related. So we're going to draw our trend line through the middle of your data. Now, just so it stands out a little bit, I'm going to make it a little thick. Okay, and I'm going to make it probably red. Oop, if I can, if it'll let me. There you go. That's not really red, but it'll work. Notice that I drew it through the middle of the data. Here's what I did not do. I did not put it underneath the data, and I didn't put it on top of the data. I drew it through the data. And that's going to help me make a prediction, okay? An accurate prediction. And you'll see what that means in the next slides. But now I'm going to go over here, and I'm going to grab a line and put it through the middle of the data again. So that's about, that one would be about there. And then this side would probably be about here, thereabouts. And if you're wondering, like, how do I draw it perfectly, sir? Well, if I just need it to be perfect. Well, then you want to draw a line that hits as many of these points as possible, or that is equal distance from each point as possible. So um, let's talk about this next one. Notice that this is positive and it was going up. We read a graph from left side to right side and it was going up. Another way to say that is that as x was increasing, y was increasing. On negative, as x was increasing, the y was going down. Because remember, x's, throw your x's to the side, you ask God why. Why did I date him? Okay. So the x axis goes side to side, and the y axis goes up and down. This one's going down as negative. But over here, these bottom two, I want you to notice something. No matter what type of line I try to draw, I can't do a straight line through this data. If I put it on that side, if I put it over here, if I were to rotate it, I mean, flip it per se. Let's see if I can do that real quick. Order, rotate, flip horizontally. That doesn't do anything for me. There's nothing I can do. I cannot put a line through that data, and that is why it is nonlinear. And over here, there is no relationship. There's no general trend or path. Now, what many of you heard me just say just now was, I don't even have to try to draw a line. That's not what I said, because then we started making mistakes. And let's look at that in our next three problems. Okay. When you saw a real problem, a lot of you just try to look at it and say, oh, I don't have to, it's just positive. I don't need to read the words. I just positive graph. I know what I'm doing. And that's not correct strategy. You do need to read and you do need to draw your trend line, especially when you see a scatter plot. So I'm going to do this slide here, number one. And number two, the expectation is that you do 11 and 12 on yours, okay? So the coaches of a group of debate teams answered a survey about hours of debate, team practice, and the number of team wins. The graph shows the results of this survey. Okay. Which best describes the relationship between the data? Is it A, that there's a positive correlation, B, a negative correlation, C, no correlation, or D, there is a parallel correlation? Well, first things first, I need to draw my line. So I need to put my line through the middle of the data, all the way through it, right? All right, I got my trend line. So from left to right, it's going up. So that's a positive correlation. So our answer would be A. So over here on the right where it says claim, my answer is A. If you want to give a more all-star answer, if you want to give a advanced answer, which I encourage you to do, you would say there is a positive correlation. Okay. Now we need to provide evidence of that and our reasoning. So before we do though, I think I want to do our claim evidence reasoning with 1 and 2 together as an example. And I'm okay if you do the same on the next slides, but on the next slide, you should only have one problem. That's correct, one problem. So anyway, based on these results, if a team practices 4 hours per week next season, which is the best estimate of the number of debates the team can expect to win? So if they practice 4 hours per week, so if I go to 4 hours per week, because it says hours of practice per week is the x-axis, 4 hours per week, that's about how many? 16 debates won. And this is why we draw a trend line. If you thought it was 20, 20 is all the way up here. That's if we had drawn our trend line above the data, you would have picked 20 and you would have been incorrect. The other option was C, 12. If you had drawn your data below the data, I mean below all the data, you would have said about 12 and you would have been incorrect. If you drew it right on the line, you would have said about 14 and you would have been incorrect. When you draw your line through the middle of the data, like you're supposed to, where each point is equal distance away, and you're touching as many points along the way, you'll see that the number of hours practiced, 4, lines up with 16 debates won. Our correct answer is B. So I'm going to combine that over here. There is a positive correlation. Okay. So that's my claim. And I also claim that, oh my goodness. Good thing there's no video here showing that I can't type. And I also claim that if they studied or if they practiced 4 hours, they would win 16 debates. Okay. That's kind of the idea here, right? So what is my evidence? Well, my evidence is that the graph was trending upwards and my trend line landed on 16, debates 1 when X was 4. And your reasoning. So I made a claim. That's my claim. Those are my answers. That it's positive, and if they practice 4 hours, they would win 16 debates. And then my evidence was shown and my reasoning. My reasoning proves my evidence, which proves my claim, okay? So my reasoning is that if the trend line was positive, it makes sense that the more they studied or practiced, the better they did. Ladies and gents, I want you to try 11 and 12 and then the exit ticket. Rewatch this video as many times as you need to be successful.